Hello everybody, and in this tutorial we'll be understanding the heart disease machine learning dataset, and we'll be doing its data visualization analysis in very comprehensive detail. Okay, so where do you get this dataset? You get it from this kernel. What you do is you go on to Google and just write heart disease machine learning dataset and go on this kaggle.com, click on this link, and it will be redirecting you to Kaggle page where you can find this. Press on this download, and your zip folder would be downloaded. What you do is you open this in the folder wherein it has been downloaded. So I go on my downloads and I extract this file, and it will ask me some details. I'll say okay, and I'll give it permission, and see, you've got this heart data set here. So what I do is I just close this and I go to my Jupyter notebook. I have this here, and what I did is I have uploaded this from this downloads, this heart, this file, and heart.csv. Since I have already uploaded it, I will not upload it, so you can just upload it. Okay, and after uploading it, what you do is you create a new Python 3 notebook, and a new Python 3 will be opened. Since I have created one notebook, heart diseases, you open that new notebook and name it as heart diseases. Okay, and we'll start the data analysis. So we'll start with loading some basic libraries: pandas, numpy for linear algebra, pandas for your file processing, and for your data set conversion, converting into a data frame, and loading your CSV, etc. Then two plotting libraries, matplotlib and cbond, and I have imported the warnings also, so that the huge pink boxes in output are avoided. So you run this code, press either run or hit shift enter simultaneously. Then what you do is read the CSV file. So reading the CSV file, all right, and I've converted into a heading. So you press here 2 and shift enter. Okay, so this is df is equals to, in a data frame called df, an object I have created, wherein I will read the CSV with the help of pandas, and the name of this is heart.csv. Go to your current directory and you see this heart.csv. This name has to be written here. So we write this heart.csv, hit shift enter, and then df.head. We'll just see the first 5 values here, and what we see is these are the first 5 values: age, sex, CP, trust, BPS, cholesterol, FBS, and so on. And we also included target here. So this CSV file already has, you know, rows and column format, just like a table. So let's see next. Now we will explore this data set to derive useful information. So how do we do that? Let's see the shape of our data. It is 303 rows and 14 columns. So these are 14 columns of features, I will say, attributes, and I have got 303 data entries, column rows, right? The next thing, I will see my column names. So this is df.columns. This is how you can retrieve the column names in the form of an array, right? Then df.describes gives you some statistical information about your data, like count 303 in all, mean, you can see the mean, the standard deviation, it also differs, the minimum, the maximum value, the minimum value, 25%, 50%, and 75% of the values. Okay, so in age, if you see, the maximum value age is 77 years and the minimum is 29 years. So in this heart disease, we've got this target as 0 and 1, as you can see. So 0 means you don't have a heart disease and 1 means you have a heart disease, and the age group is 29 to 77. Okay, and sex is also, we see here, as male and female. And I can just show you the details of this data set. So the sex, 1 means male and 0 means female. Then CP is chest pain, and this rest BPS is resting blood pressure, call is cholesterol, FPS is fasting sugar, and it is greater than 120 mg per dl, then it is true. 1 is true and 0 is false. Then you've got various other features. Thallium, maximum heart rate achieved, old peak is there. This is something called depression, which has been induced by exercise relative to rest. Okay, depression due to exercise. CA is your major vessel colored by fluoroscopy. Thal is your 3 is normal, 6, and these are the values which are being given for thal. And target is 1, that means you have heart disease, and 0, that means you do not have heart diseases. So this is what it is. And if you scroll this further, you can understand further with this. So let's go to our Jupyter notebook, and you can just see this few things, minimum maximum values. Now let's go on further with exploring any null values in it. So we'll write is df dot is null dot sum, and we find that there are no null values. There are 0 null values, which is good that you don't have to fill any data here. You don't have to fill these values. And what I do is I print df.info, and what is the significance of this is you'll see that I can find the data type and I can find the null value count here, and I see that there are no null values. Everything is being printed in a very descriptive form when I write this information of my data set where I have stored it. So you can see that all is in numeric format and I don't have to convert them. So this is also good. Okay, so no categorical data. Now what you do is you find the correlation. Let's come to finding the correlation, if any. So we'll use the SNS, the steam map heat map feature here, and I will write df.corr and a note is true, which will print the values inside, and I have given terrain is this steam map. So you can see here that this is high positively correlated and this is negatively correlated, right? So now with the target, what is the relation of age? So this is a negative correlation. That means if you have a heart disease, it's likely that you are of higher age, right? Sex is of, so the negative correlation is with age, sex, then this resting BPS, blood pressure, cholesterol, this is very low, FPS and CA, right? Thal. Let's see the positive correlation, and we see the positive correlation between the target and CP. This is chest pain. So the more the chest pain, likely to have a heart disease, heart attack, or so. Then we have got thallac. This is also positively related. Slope is also positively related. So you can see that positive and negative values, how they are related with each other. All right. So let's proceed on to seeing some scattering, some linear relation if there's any. So we see this data distribution, the correlation between two variables with the help of pair plot also. So we pair plot, you just plot it and it will be plotted for all the 14 features we have. And we see some scattering over here, some relationship which is actually there's no direction here, and you can see some relation but not so clear. this is chest pain, and it is divided into various parts. See, 1, 2, 3, 4. This is what we'll explore further. And this is like I don't know what it is it telling us. So let's explore further. Okay, let's see the shape of our data. How our data looks like. So what you do is you plot this df.hist.figure. I would set the figure size as 12,12, and this layout is 5,3. That means 5 rows and 3 columns, right? So I give this, because I have got 14 features to be plotted, so I have to give it 5 into 3 is 15. So I have to give it greater than it or equal to that. So that's 5 rows and column like plotted like 3. So understand this layout, and you can see this distribution of age here, that the lowest age is, you know, um, like below 30, that is 29 we have seen, and the maximum age is goes above 70, 75. So it's 77 we've seen in the description. And you see this CA, it's having, there's 4 values, 5 values, 0, 1, 2, 3, 4. And the cholesterol level distribution, highest goes to like more than 500. Okay, and the chest pain is 0, and the people having chest pain as very less chest pain is quite high in number. That means we've got low cases. Let's see, this is a hypothesis which I am just telling you, that there are lower cases of heart attack, and we'll explore it further. And chest pain having 2 is higher than second ranking. Okay, that means people will be having heart attack here. Okay, then this is the blood fasting sugar. Okay, now you see the sex here, 0 is females and 1 is male. Please remember this thing. The target is again 0, that means no heart attack, and heart attack 1. And then you've got various features here. See the distribution of your data. Now let's just see any outliers. Basically box and whiskers plot will let us know this, and I have plotted this using PLT, that means matplotlib library, and you plot this box plot and layout again 5:3, and figure size is 12,12, so that it fits in. And we see that yes, we have got outliers in age. Okay, we've got it in cholesterol, we've got it in CA, old peak, thal. Okay, fine. So let's come to individual plotting of various features and understanding their relationship, how to decipher and what to understand. So we've got various plots here, like sns.cat plot. I'm taking category plot here, and I go, this is how I write it. Data is df. In the x-axis I want sex, and in the y-axis I want age, and hue is target, and palette is HUSL. So what I get is this. I get here 0, that is females having heart diseases, is plotted with this teal color, and you can see this range between the age, like most of the females are in the age of like more than 40 to more than 70 years who are having heart diseases, right? And the females who are not having any heart diseases are very few, and they are also scattered among different age groups, right? And it starts from the age group of above 40. Similarly, in case of males, one is male, and you see having males having, see, this is an outlier, extreme low value, and also males not having any heart attack in the age greater than 70. And we see in males that the percentage of males not having heart diseases is greater as compared to percentage of females here, right? Okay, so we'll explore it further and we'll get more clarity with more plots. Okay, let's on go to plotting bar plot. On our axis we'll have sex, and on y we'll have cholesterol level, and hue would be target. Okay, so let's see how the cholesterol level of various males and females they have, and what does it show. right? So this simply shows that these females having the cholesterol level, having not having heart diseases and having heart diseases, and having heart diseases greater than 250, not having greater than 270. So like, and the cholesterol level is quite high, still they're not having the diseases. So okay. And here also in males, not having heart diseases but still the cholesterol levels are high, so you can just infer that okay, cholesterol is not that much, giving us much detail about this. So we'll explore further. And okay, I tell you how the value counts work. So we've seen the value counts, like how many males are there, how many females are there. So there are 207 males and 96 females. Okay, now let's see the target. That means having heart disease is 165 and not having heart disease is 168. So among this 165 there will be males and females, and among this not having also there will be males and females. The distribution would be in both. So let's print this thal. This thal is the thallium stress test. Okay, and this measures the blood flow to the heart, and it has got various levels like 0, 1, 2, 3. And you can see the count here that 0 is 2, 1 is 18, 3 and 2. So if you want to plot it, what I have done is first I have plotted this with males and females, and how many males and females, the count plot if you want to plot it and see the males having heart diseases and males not having heart diseases. Similarly, females not having heart diseases is less and having heart diseases is more. Okay, right, because hue tells us 0 as not having heart disease and 1 is having heart disease. Okay, um, now let's plot this count plot for target, because we have seen the value comes, and also you can just see it by plotting it. So we can see here 0 and having diseases and not having diseases. Next, look at CA. Okay, so the CA is the major vessels, and they are ranked to 0 to 3, that means 4, and they are colored by fluoroscopy, right? So I plotted on x-axis and the count it has been giving me of having, not having and having, right? I can just simply also write here sex, so I can understand that males and females having this blood vessels, major blood vessels colored and the distribution in this plot. So you can play around with different features here. It will be very interesting to know. And next is like, we can just do the value count if you want, and this is how I just did it, 0 to 4. This is the value count of it. And now let's do some count plot of thal. This is the, again, the test, right? The blood pressure, the blood flow. So you see that 2, and you also, like, the hue is written here that if it is 2, there are greater chances of having heart diseases. See, it's 2, it's the highest. And you can also set here hue as sex. Okay, so you can understand that males and females having that. Okay, now what you do is, similarly I have plotted it of sex, so you understand that the males and females. Okay, this is females and this is males, so that means 2 is dangerous because you've got it high in males and females both, right? And then this is CP, the chest pain, and when chest pain is 2, you've got heart attacks, 87. So let's just plot this and with the heart attacks. So you see this heart attack and you see this thing. So when the chest pain is 2, heart attacks are maximum. Okay, and when you don't have, that means you don't have it, right? Okay, so still there are cases when you don't have a heart attack, but still you have cases with this. Okay, now let's come to plotting the chest pain with the sex. How many males and females have chest pain? So we find that the number of females having chest pain is 0, but males having chest pain at the intensity of 0 is much higher as compared to females. And then in the two categories we come then females and males. So males are outnumbering females, but yes, females are also having greater percentage, as you can see. Now box plot, just a different variation of box plot, which tells me the outlier in sex and your cholesterol levels, and the target is this hue is the target, which tells me um, you know not having heart disease and having heart diseases. So this having heart diseases have outliers. That means that people, the females having heart diseases which are either very low of age or very high age, and same similarly goes with the males, right? Okay, what next is the bar plot is for this bar plot is for so some like this is for x-axis males and females, and I have plotted here chest plane. So this is like same, but just exploring the data. You can do it yourself. The next thing I have experimented with thal here, and you plot it and you see it by yourself. How does it look like? There are many plots like this. You can experiment with different features, and I'll leave this code in my GitHub link. Do visit it. It will be provided in the description box. I will go through one more and then I'll show you something really very interesting. So just see that this is a feature. Again, I have plotted this sex and old peak. This old peak is what it is, the depression which is induced by exercise relative to rest. So please rest. Exercise would not help you cure heart diseases. And this is an abnormality of electrocardiograms, and this plot shows that if you are not resting well, you are prone to have heart disease despite of having exercises. And you see that the target, um, like having heart diseases, females despite of having exercise, it's quite a number, good number. And here also males, right? Okay, so fasting blood sugar which is greater than 120 is again being plotted, and you can see the count of it. When it is less than 120, it's 258, and it's more, it's 45. So I have plotted this blood sugar with cholesterol level, and you can see this with having you know heart disease and not having the heart disease. You can just compare the two. Next we come to, again I have just bar plotted this, and you can just see that. Next I come to something interesting which is called cross tables, and this is what it looks like. So what I do is I create an object, and that I take the help of pandas, and I create a cross table of the sex and the target, and I print this. So what it gives me, the target, that means having, not having, and having heart disease. And this is females and males. So females not having cancer or heart disease, sorry, is 24, and having heart disease is 72. Males not having heart disease 114, and having heart disease is 93. And when you plot it with this code, you can see the distribution easily. Okay, this is how it is being distributed. See how beautiful it looks. So these are various features with SNS, and Matplotlib provides you to represent your data, right? Next I'll show you something called okay, let's plot it with thal. That means this level, this test. So again I will plot a cross table for this sex, and columns would be thal and margins is true. So I just get this thal values are 0 1 2 3, and all is combined, and this is like females having these values. So the 2 is the greatest in females, and for males 102, third is the highest, right? And this is the sum total of all. So when you plot it, what you get is, I get something like this, a stacked for females, for males, and for both. So you can just see that if the thal is 2, that means if the thal is more, then there are likely chances that you might get a heart attack, right? A heart disease. Okay. Now what you can do is you can play around with this. Now I am plotting this DF I'm taking as target. Previously I have taken sex. Now I'll take heart disease and I'll compare it with whether it is true, and I just plot this, and this is the values which I got. That for not having the thal is 36, and if it has become 3, then the chances of not having a heart disease is much higher, is lower. Okay, not having is higher here. Now when you plot it, what you get is like this. So that means if you're having thal as 130, that means you're likely to have much higher heart disease. Okay, so see, this is what it shows. Again, the green color is bar is much having much greater share as compared to others, and this shows that yes, you are having heart disease. So you can relate the two by showing various plots, right? Again, if you want, you can just do it for this thing, like for the chest pain and for the target. Again, you can just plot it and see for yourself the chest pain, what level chest pain you have, and do you really get heart disease. So this is like not having and having the heart disease, and I have got these level of chest pains, and the 2 here. See, if I get a level of 2, my chances of having heart disease increases, okay, as compared to 0, 1 and 3, right? So that's all for this video, and I think we have done with most of the data visualization and data exploration. It was a very easy data set of type of heart diseases, and download it and read the CSV file with help of pandas. And in the end, I would just say that guys, please keep practicing, because this is very easy, and this is very interesting, and practice is the key. If you won't write the code in Jupyter, you won't understand anything. Even if after getting the code you won't practice, it is of no help. So just keep practicing, enjoy the process, and in the next video we shall see the model building process of the same heart disease example, and which will be included in the second part. So stay tuned for that, and all the best, and thank you for watching.